Hi, my name is Jeremy Ranksteiner, and I'll be talking about a case study about how LiDAR can be used to prevent mudslide casualties. So originally I had planned on going in a different direction, but when I came across this case study, I couldn't pass it up. This happened in Oso, Washington, which is about 45 minutes from my home in Seattle, and I worked for David Evans and Associates on a survey crew, and we were hired to do the ground truthing for this LiDAR project, so I couldn't pass it up when I found this. If you look here on the left side, you see the yellow outline shows the scope of the slide. All the red outlines show houses and smaller buildings. And then if you look on the right side, you can see just how devastating that slide was. Just the entire side of that mountain slid down. So in March 26, 2014, this slide happened 4 miles east of Oso, Washington. Except for earthquakes, volcanoes, and failed dams, it's the deadliest landslide in U.S. history. It covered over a square mile, which might not sound like a lot, but when you think about how many people live in a subdivision in a 1 mile by 1 mile area, you realize how devastating that can be. It killed 43 people and just completely took out the entire neighborhood. These pictures on the right here are pictures I took. You can see our crew trucks down there, and just those are the best I could get just to show the scope of what it was like. It was a little eerie walking around knowing that there was an entire neighborhood buried underneath those mounds of mud. Completely dammed the Stillaguamish River, which ran right through that valley, and backed it up miles up into the valley, which made it much more difficult for emergency workers to get in there and look for people. And it also took out State Route 530, which was the state highway which went through the town. So how can LiDAR help? It helps geologists study past events, which can help predict future problems. If you look here on the left, this is a slope analysis from a LiDAR raster. There was a slide that happened on the same slope in 2006, and that is outlined in the yellow here on the left side. Much smaller in scope, but still a good indication of things to come. The problem is that that neighborhood had been there since about the 50s, and people can't really just afford to leave their homes. So that's another problem all on its own. If you look here on the right side, that shows the effects of the landslide in 2006. The red is where the elevation sank most drastically, and then the green is where it rose as it slid off that hill. And these are some hill shades that come from a LiDAR raster. They used LiDAR and ground penetrating radar to uncover small morphological changes in the surface and soil content that were previously undetectable. These images show the impact of the slides, but they also show the headscarp from a prehistoric slide event. So if you look here on the left side in the northwesternly area, you can see a sharp edge to that cliff there where that slid off prior to any people settling in the area. The yellow dotted line outlines the 2006 slide, and then on the right side, it's most obvious, the red shaded area is the 2014 slide, which obviously took out a much bigger area. But you can see even in the difference between the 2003 and the 2014 images, the slide that happened in 2006 completely rerouted the river right through the middle of that valley, whereas before it had been closer to the base of that hill. So in the future, LiDAR, I think, can be used and will be used to greatly improve these sort of safety recommendations. Oregon and Washington are now using LiDAR to develop landslide databases. The Oregon Department of Geology and Mineral Industries has mapped over 41,000 landslide areas, which is vastly increased from the 12,000 in 2009. The Puget Sound LiDAR Consortium is an informal group of local agency staff and federal research scientists, which is devoted to maintaining a public domain LiDAR database. And as with most technologies, accuracy and accessibility is improving, at a great rate. And because of that, the price is coming down. LiDAR, I think, will continue to help solve these problems by finding landslides that have already happened, which may not have been apparent to the naked eye, and will reveal indications of future instability and hopefully have an impact on where future neighborhoods are built. And here's my reference from the Earth Imaging Journal, September 27th. Thanks for listening.